As far as the agenda today, we're going to be starting initially with the overview of common mold types, the different types of molds that people use in the industry, and the different types of molds that we can machine in our product, as well as the mold type that our customers are generally machining. We're going to be talking about general CAM strategies for creating these mold cores and cavities using the 2 and the 3-axis toolpath methods in our system. And also we'll talk a little bit about choosing the right toolpath methods to achieve the best results that you're looking for. And then also some power techniques in terms of tips and techniques for parting line machining, which is very important for mold makers, especially for plastic injection molding. And then also we're going to be talking about some of the advanced machining methods we have in our system to allow you to get these types of molds machined in the best possible manner. Before we get started, I also want to tell you that the best product for you if you're a mold maker would be the combination of Rhino and Rhino CAM. And also the configuration that we would recommend for mold makers would be the Rhino CAM Pro configuration. So keep that in mind as Don is going through the demonstration. All right, Don, take it away.
Hello, everyone. Thanks for being here with us today for our mold machining webinar. We're going to talk a little bit about the different types of castings and molds that typically our product is used to machine. And I've lined these up from left to right in order of accuracy required. So on the left, we've got Thermoform Examples. And if you notice, take a look at that graphic on the left. Thermoforming, it just drapes a heated sheet of plastic over a core model. So all your machining in our product is the actual core. And so you don't have to machine any cavities or anything. And typically the tolerances are relatively loose. The only thing you need to make sure is that you have the right amount of draft, because that plastic has to slip off of that core very easily. So in the middle, we move from thermoforming to casting. Now casting, in casting, you need to machine both a blank in order to create the cavities. It's kind of a different way of doing it than injection molding, where you're just shooting in plastic, in a core and cavity. In casting, you are actually molding the cavities from a blank. So you got to create that blank, machine that blank ahead of time, and then you use that to mold or to form each half of the mold. And the material is like a green sand that's sticks together, and it creates a cavity from that blank. And on the right, obviously, and we're going to be spending most of our time on plastic injection molding. And just as an overview, plastic injection molding, you're using cores and cavities and injecting various plastics, ABS, polypropylene, many different types of plastics under very high pressure into these cavities. So this, we're going to be talking about the core. If you look at this graphic, you see the cavity there in yellow. So we're going to be talking about primarily in machining the cavity half of this mold. So these are inserts that you insert into the mold in order to create the cavity, in order to, obviously, to injection mold it. Let's go to the next slide. Now, first, we're going to talk about the thermoforming. As I mentioned, in thermoforming, you're just machining a core blank. And in thermoform, there's a picture of it right here, a couple examples. On the left, we have an example from the Warren Group, which makes thermoform packaging, display packaging, and also product packaging, where they're draping clear plastic over a core mold in order to create the end product. And then on the right, we have an example from South Dakota State University of a student project where the core components are machined out of stock material, and then they're set on the thermoform machine, and then the plastic is formed over it. So thermoforming, like I mentioned, is the least amount of accuracy that you need to worry about, primarily draft. So you want to make sure you have enough draft to get that plastic up off of that core. Now, next up is cast mold examples. I mentioned previously that you need to have a blank in order to create a cavity, in order to create a casted part. And the final casted part is obviously the part you're going to machine, which is your production component. But uniquely, you also have to create the blank. So you have to machine that as well. And then you use that. If you look at the section view on the left, it shows the two halves of the casting mold in orange. And then the casted material is poured into the gray areas, so to form the actual product. If you move over there to the far right, this is the end result of the casted product. So you want to be machining the blank, and you got to be machining the final product. Just one second. Okay, here's another example of a cast molded part where, again, you have to have a blank. So we have the casted blank over here on the left side near the bottom, and that needs to be modeled and created. Now, you can actually, in order to create this blank, you can also create a prototype mold with a cavity and core in order to mold the blank. The blank doesn't have to be obviously as accurate. It's, as your finished product, because you're going to be machining this blank in areas that are functional for this part. So in the top and right areas, we show both sides of this blank after they're machined. So you got machining on one side, and then you flip it over, and we have fixture plates to illustrate that process. Again, if anybody's got any questions, put them in the chat window, and we'll get to them. Okay, so that's another casted mold example. Now, the big guy on the block, insert injection molding. So there's a lot of things on this screen, so I'm going to go a little bit in detail and start from the right top area. So we have our end result product, which is a pair of sunglasses. You don't see through them. They're all plastic. They're probably molded in black plastic. So below that, you see one half of the cavity insert, okay? And then below that, you see the same insert with a protection surface draped over it. And we're going to talk in detail about these protection surfaces and how they're used to machine the inserts, but primarily what they're used to protect the parting line. And if you move over from there, in the middle, you see two examples of injection molding defects. On the right, you see flash, which can occur if your parting line has been sufficiently degraded. So you need to take care of that parting line, and we're going to show you how to do that. And then on the left shows a mismatch in the parting line. Now, the mismatch can occur if your tolerances aren't tight enough, if your setup is not correct, things of that nature. So on the right, we got the flash, which is caused by degrading of the parting line. And then on the left, we have mismatch, which can be caused by incorrect setup or incorrect tolerances. So let's move directly above that. Now, a subset of cavity and core inserts in a mold. Obviously, you think of a mold, you think, okay, we're just going to blow some plastic in it, and then we're going to have a part, and then everyone's hunky-dory. But that's not the case. You will have a prototype mold, which you create some prototype parts. Your engineering customer will review those molds. They'll make changes. They'll take the parts. They'll mark them up. They'll actually take a marker and write it, write on the part. Say I want more material here. I want less material there. We need to make revisions. So the mold maker will make sets of inserts. So he's probably going to machine at least 2 sets and possibly even more, just for that purpose, for revisions and whatnot. And if those revisions get to such an extent that the mold cannot be revised anymore, either by adding material into the mold, and this is done regularly, they'll actually, in a typically welding process, where they'll add material into the cavity so that they can remove it, with revisions in it, or more precisely, they can cut holes in that insert using a wire EDM machine to get a precise insert measurement, where you can redesign an insert to go in the insert, which contains the revision. So this is, primarily the reason why precision is the utmost concern in plastic injection molds. Now on the far left.
Just a note here, I just wanted to let you know, Don in his previous life was a mold maker, and so just wanted to let you know he knows what he's talking about. So just to give him a little bit of encouragement here.
Well, just a note here, I could only hack mold making for 2 years. It was very, very demanding. And you guys know, if you're making molds, especially if you're in the automotive industry or aeronautics industry, it's a very demanding profession to be in. So hats off to you guys for being able to stick it out longer than I was able to. Okay, so on the far left, if you've created cavities, then you know about EDM machining, electronic discharge machining, where you're taking a core and a cavity, and one half of the cavity is typically it's made out of graphite, and it is used to actually burn a cavity into your insert. Both the cavity and the graphite are submerged in a dielectric solution, and the precision that these two components are getting closer and closer to each other, about 4 thousandths apart, the electricity starts arcing from from your insert to your graphite, and both parts are actually vaporized in the process. But what you're left with is a perfectly formed cavity that you don't need any finishing, you don't need to do anything else. So this is a very, as long as your graphite core is machined properly, that's exactly what you're going to see in the cavity. Okay, so if anybody has any questions on mold inserts, please put them in the chat window. So when we get to the demo area, we're going to be spending a lot of time on this particular part, and I'm going to show you the best way to machine those parting lines. Okay, here we have, I wanted to use just a basic insert example to illustrate the techniques I'm going to show you. What we have is a very basic insert. We have a cavity, we have a parting surface around the cavity, and then between the two, we have the parting line. And we're going to show you the best way to machine the cavity as well as the parting surface, and how to protect that parting line. If you don't protect that parting line, mold makers, you understand, if you don't protect that parting line, you're not going to be machining molds for very long. So your customer will just give it back to you and say, redo it. So you don't want to do that. Now, we're also going to talk about some tips. Joe mentioned some tips and techniques for machining. These apply to plastic injection mold. So from here out, as far as the demo portion, we're primarily going to be talking about plastic injection molding, but we're going to just show you some parts as well for the other two. So if we start up on the left, we have, it's called dial in your accuracy. Now, obviously for injection molding inserts, the accuracy is very great. You'll be dialing in this accuracy. The precision is very high on these inserts, especially in the parting line area near your cavity and your parting plane and your parting surface. And we're going to show you how to dial in that accuracy. From there, we'll go down to the cutting tools. We're going to talk a little bit about, as a generic rule, which types of tools are better to use than others. And then over here on the bottom right, we see what we call them protection surfaces. So we're going to show you how to add protection surfaces to your inserts in order to protect them while you're machining them. And then up on the top right, we're going to show you what I'm calling the first contact rule. And I'll get into that in more detail. But basically from the illustration, you get the gist of the rule. And we'll go into that in more detail in just a moment. Oh, let me go back one. Okay. Dialing in your accuracy. We have 6 areas in RhinoCAM that you want to check and adjust depending on the accuracy requirements of your customer. And typically you will start in the arc fitting tolerance. Obviously, if you're fitting arcs on your cavity, you want that to be your final highest resolution accuracy. And from there, we'll back off and do the CAM operational global tolerance. And I'm going to go through these and show you in the part. But typically, you want to do your arc fitting tolerance. In our example, we're starting with 1,000th. And then the CAM global tolerance is half of the arc fitting tolerance. So that would be 1/1000th. And then we're going to look at setting the CAD geometry tolerance. So we're adding 2 more decimal places to that just for rounding. And then we're going to look at how to adjust the CAM part sampling resolution. This is a setting in the CAM preferences which affects your accuracy of your machining. Also, we're just going to touch base on the tool just to make sure that you have all of the decimal places filled out on your tool. If you need a 3/8 tool, don't enter 3.37, okay? You want to use all the decimal places you need to fully define that tool diameter. And then lastly, but not leastly, before you post, you want to go into your post processor and make sure that you have the correct number of decimal places being posted. If you do all of them, 1, 2, 3, 4, and 5, but you don't adjust the output in your post, it's all for naught because you won't see it in the output coordinates. Again, any questions? Everyone holler, okay? Okay, the next tip or technique is for the cutting tool. Basically, what we're trying to get across here is that you want the stoutest cutting tool that you can use, the largest diameter, the largest shaft diameter, which will, and the shortest length of the tool, which will create a very strong tool. It'll eliminate any deflection in the tool, and that's what you want. And then and on this tool, we show a taper. Obviously, if you have a part that needs draft and your part doesn't have the draft, then obviously you're going to want to use a taper tool in order to machine that draft automatically. So on the right, we see a no-no. We see a long, narrow tool, small diameter, a lot of deflection going on in that tool, especially if you're machining hard materials, sometimes you'll have to come back and do revisions after that. Those inserts have already been heat treated. So very strong steel that you're going to have to cut. So you want to stay away from very long tools, which can affect your resolution and tolerance. Now, the third technique we're going to show you is the protection surfaces. And by protection surfaces, in our example insert, you see that we have added extensions to the cavity surfaces, and we have added extensions to the parting surface of the mold. So here on the parting surface, you see that it extends out past the mold on each side. And these are really, they're not complex to create, and I'm going to show you how to create them in Rhino. And Rhino is the best product to use for, in my opinion, to use for injection molding, especially for the surface modeling that you're going to need. So on the right, we see the cavity extensions and how they're extending up past the parting line. And as the description testifies, these surfacers are playing interference with your parting line. It's protecting it from the tool. So we don't want the tool to beat up on the parting line. You don't want it to run over the parting line. You don't want it to roll over the parting line. And you don't want it to roll along the parting line. You want a nice clean cut across that parting line. And we're going to show you how to achieve that. Now, in our example part, we did do, ahead of time, I did the roughing and re-roughing of this part. And just as a note, in the re-roughing, that is a Pro configuration toolpath. In the Pro and Advanced 3-axis, you get a whole range of toolpath methods that can use exclusively for mold making. And we're going to go over those a little bit later. So the final technique I guess we're going to get across is what I'm calling the first contact rule for machining parting lines, cavities, and parting surfaces. If you consider yourself the tool and you're running along this parting surface and you hit that parting line, the first contact rule states that you will not touch that same point on that parting line again in the same operation. So that tool will just say, howdy parting line, I'm going on my way. It's touched it and it's continuing to cut in other areas. It doesn't stop on the parting line. Like I mentioned, it doesn't roll over the parting line, and it doesn't roll along the parting line. And that's what these protection surfaces are used for. So they're going to show you, basically I'm telling you how to do it, but we're going to show you the end result of using this technique and not using this technique. And it's very stark comparison. Now, we see here after using the first contact rule and not using the first contact rule. So on the left, we have the cavity machined out and we have the parting surface machined out. On the right top, you will see the cavity, cut material simulation of the cavity, the entire insert with the first contact rule implemented. So you see a nice, clear parting line, very distinct. There's no colors bleeding from one side to another. And if you go in the middle image, you'll see that. You'll see areas where the cavity is bleeding over into the parting surface and vice versa. This area, you're allowing the tool to literally beat up on the parting line, and that's going to cause flash. Not so much mismatch because of your accuracy, but you're going to get flash, and you're going to see this in your prototypes when they come out of your inserts. Out of your cavity inserts, and you're just going to be throwing this cavity in the trash bin because it's not any good. And here's just a close-up of the one contact rule on the right, nice and clean, very precise, no bleeding from one side to another. versus on the left. And this is literally how your insert's going to come out. I mean, you're going to be machining up on your parting surface when you're supposed to be machining your cavity, and vice versa. And there's nothing you can do about this if you don't use these protection surfaces. And I'll show you that as well. Joe, is there any questions? If you have any questions.
No, you're doing fine, Don.
Okay.
There's some comments, but there's a lot of experts seem like to be watching today, so they know what they're doing. So continue,
great.
please.
Okay, so there's our first contact rule up close. Now, we have published some documents and articles relating to mold insert machining, parting line machining. I'm going to put, when we send you to the webinar replay, I'm going to put links in there that where you can get to these articles and read them for reference.